If you ask me what sustainability is, I think as a layperson, I would just say something like the ability to sustain. But I don't think you're here to listen to that. But you're here to listen to more. And hence, we just have the right people to share their knowledge on this topic today. Without taking another moment further on and wasting your time, I'm going to request the speakers of this conclave to please step forward to light the lamp. And while they step forward, let's create an ambience by putting our hands together for... And finally, Dr. V.P. Raman, who's going to be moderator. He goes playing a key role in today's discussion. So gentlemen, put together your hands and just light this lamp as a sign of positivity. Gentlemen, I'm going to request you to please step up on the dais and take your seats.
As a moderator, I have to light up all the banners.
Well, I think I'm going to just find the right person among all to give the keynote address. With almost 50 golden years of experience, we know him more because of his association with automation since 2002. And then we've had pulled along 15 wonderful shows of success. If anyone would say, what's in the name? Today, I would say with pride, it's all in the name. We don't need anything more to know about him. All you need to know is just his name, and you know it all. Ladies and gentlemen, for the keynote address, Dr. B.R. Mehta.
Thank you. So today's our topic is sustainability. And one of the major way of achieving the sustainability is innovating to zero. What I mean to say is we have to go to set out our principles for innovating to zero. And what we are going to do and look for is zero emission vehicles. What we are going to look for is zero emission vehicles, zero waste, zero accidents, zero defects, zero security breaches, zero carbon emission, and zero obesity and even zero disease. This is a very good aim, and many countries have started thinking, and a lot of things are happening in the world to go towards innovating to zero. If we talk about India, one of the major group, Tata Group of companies, 7 major companies have combined, and they have launched a project called Project Alingan. In their words, it is an embracement, it embraces in Sanskrit, embodies the Tata Group's vision for a greener, cleaner, more sustainable and equitable future of the planet. Alingan outlines the Tata approach to planet resilience, the group's aspiration of net zero by 2045. and the vision of securing the future to innovating today. Actually, they started this vision many, many years back in 90s when they started producing trucks. And they say that we did not have to create a lake to produce the trucks, but to match it with the sustainability thing in their mind. They created a large lake, and it is a wonderful thing to see near their plant. What they say is driving the decarbonization of our business and value chain, applying a systematic circular economy approach to reduce resource use and waste, and preserving and restoring the natural environment is the goal of their company. And this is the biggest channel for human mankind for the next decade to come. And for our children and grandchildren to be happy, we need to make sure that we always innovate to zero and get them a better future where they can be more sustainable. Now let's start look at our work. We have first, as a byproduct of Corona, you can say, all started doing digitization. And we all started working from home. That means we made a paperless office. And we reduced the waste of paper, which is again a sustainability cost. And by doing this, what we saved is the cost savings, easier remote collaboration, better document management and less time searching of files, environmental consideration, as I said, easier onboarding and other HR processes, the ability to offer a better customer experience, more transparent and efficient finance processes, and greater document security. So this is what we achieved by doing the digitization and the paperless office. Look at the cities. Now, most of the cities in Europe, they have started decarbonization and they are helping with replacing the fuel with a regenerative fuel, maybe the electrical cars or the hydrogen. And they are also promoting not using the fuel. And I have put in a picture where government of Denmark, Copenhagen, in the middle of the areas, they have these cycle parks where many senior officers also come and park the cycles, and they avoiding use of petrol and diesel. The same thing happens in Holland. They have made a lot of roads parallel to the main road where you can cycle to the office. I have seen many, many officers, very senior level, driving to their office by a cycle. Looking at our buildings, we have to go for a carbon neutral building that will reduce and use the solar, hydrogen as a fuel. The building will have no waste. I'm going to look at the waste part of it. We need to go. These are a couple of pictures of the green building that you can see in, and another one, second one is a supermarket hub where you can get these vegetable trees readily made and you can pick it up and you can use it. This reduces the waste. There is a consortium called Zero Waste. Sorry. This is running. Oh. Okay, this Zero Waste Consortium has a definition of a goal that ethical, economical, and efficient and visionary to guide people in changing their lifestyles and practices to emulate sustainable natural cycles, where all discarded materials are designed to become resource for the other use. And to give that example, you can say that they are using 3 types of bins called gray bins, green bins, and blue bins, where you can use these things for landfilling, you can use these fields for recycling, etc., and you try to reduce the waste to the best minimum. The next part is our transport. This is one of the examples of reducing the wood which was used for cremation in Hindu grounds. For a body, it was actually needing about 400 plus kg of wood to burn one body. Today it has been changed to electrical, where the time is not 4 hours, but it is almost less than 1 hour. And you can have a much better environment even nearby the cremation grounds. Co-benefits of net zero, it is I just put in the slides, but health and well-being, prosperity and environment, these are the main co-benefits of the net zero. Let's look at the transport. Transport has done a lot of things to enhance the sustainability. One of them is using the electrical vehicles, the zero emission cars. And this is also giving a direction in which we have to go. And slowly, slowly you will see that the entire world is going for either electrical car or hydrogen car where regenerative fuels will be used. What is this? I'm not sure what's happening. Okay, so the next generation we are going to look at digital systems which can do everything, everywhere, every day, everyone and connected. That is the aim of the digital system, and our aim is also to have a zero downtime. Zero downtime we can achieve. Earlier we are doing reactive maintenance and preventive maintenance. Today we do predictive maintenance, proactive maintenance, and the last step will be the self-maintenance for the zero downtime. So look at the future plant. Our future plants will then be horizontally and vertically integrated from sensor to boardroom and from crude to the retail outlet of the fuel. Most of the instrumentation available will be self-diagnostic and self-healing. Wireless can be a major thing to replace many items. Nanotechnology, most of things will be remotely operated, no environmental pollution, positive carbon footprint, smart and green. The future one will be clean, silent, safe, empty, and maybe boring because nothing has to be done by the operator. What is the plan of preservation? The way we can preserve maximum is first by prevention, then by minimization of the waste, then reuse of the products, recycling of the products, energy recovery, and the last chance is the disposal. The same philosophy will be also applying to the medical sciences, and you will see that the hospitals are also going to aspire for the net zero. They will have their own equipments to get rid of the waste. So nothing comes out of the hospital and everything will be safe and reusable. So with this, I would like to say that we can achieve more sustainability by going to net zero. Every country is trying to do these net zero applications. And with these remarks, I would like to say thank you very much for the patient hearing.
Thank you, Dr. Mehta. Our next speaker has his expertise on process control, PID controller, model predictive control, state and parameter estimation, fault detection and diagnosis, fault tolerant control, SOP sensing, and state estimation. Did the list be too long? Well, of course, it certainly is, and there's so much more. To share his knowledge on the topic Back to Basics, let's welcome Professor and Dean, Madras Institute of Technology, Professor Dr. Prakash.
Very good evening to one and all present here. At the outset, I would like to thank the organizers for having given me this opportunity. I'm Professor Prakash. My area of specialization is process control and instrumentation. I'm currently the Dean of Madras Institute of Technology campus. And first, I would like to draw the attention of CEOs who have gathered here. Every year, we used to hold a fresher welcome, and the students they make a standard statement that my first choice, in our department we used to hold a fresher welcome, and in our department we are offering B, electronics and instrumentation engineering, and the statement that every student they'll make is, my first choice was not B, electronics and instrumentation engineering, without knowing that there are plethora of opportunities for automation engineers. And in the middle of their academic career, maybe at the end of the second year, they used to approach us and they'll ask us to offer more computer science based electives, information technology based electives rather than core electives in the field of core engineering, stating that they don't want to sit for core placement, and their interest is towards IT field. That's the request they'll make, and as a result, no. The drawback is, like, we have very good expertise in our department. We have state-of-the-art facility in terms of academic infrastructure, research and innovation infrastructure, but students are not making use of the facility. And what I foresee is there is going to be shortage of skilled manpower in the field of automation. And at this juncture, I would like to seek the support of all the CEOs who have gathered here, and we have to discuss, deliberate, and find an optimal solution, and thereby we'll be able to attract students to the field of core engineering. And I have a few ideas in which I would like to share in my today's presentation. The first idea which I would like to present is we have to promote industry-institute interaction at the school level. And for this, the nearby industry should sign an MOU with school. But what is happening now, most of the industries, they're signing MOU with universities and colleges. Instead, no. The focus should be, like, we have to sign MOU, the industry should sign MOU with a school. And continuous interaction should happen between practitioners and students. And the engineers know they should visit either the school, or students should be invited to the industry, and engineers should share their success stories and whatever the trends that are happening in the field of, not only in automation, in all other core engineering domain, that should be shared with school kids. And of course, in turn also we have to provide guidance, career guidance, how to be provided. As a result, we'll be able to, what I would say is, we can enhance the core competency skill of students, and we'll be able to attract students into core engineering. Otherwise, most of the students they will, their first choice will be IT. And in addition to that, we have to organize conferences, hackathons, mobathons exclusively for school students. And so thereby we'll be able to kindle interest. That is very important. And we should invite students to participate in conferences, workshops, seminar, and thereby they'll come to know about recent trends in field of not only in automation, another domain. So continuous interaction should happen. As a result, we'll be able to kindle interest, and thereby we'll be able to attract students to pursue engineering in core domain. Otherwise, students will prefer only information technology and computer science. I'm not saying the students should not learn IT skills. They have to learn IT, in addition to core engineering. If they can learn IT skills, definitely core industry will be benefited. So this is my first solution. And the second idea is, it's not moving. It's not working now. Is it working? Yeah. And as I had mentioned that we have to increase the number of skilled personnel in core engineering by recognizing what we have to do is that we have to organize many technical events. We should allow students to participate in conferences, workshop, and thereby we'll be able to spot the talent, handhold them, nurture the talent, and we should help them in upskilling their talents by, like, for example, we should provide technical support, financial support. As a result, they'll be able to pursue engineering in the field of, I would say, automation or electronics and instrumentation. As a result, we'll be able to maximize the talent pool in the field of automation. So this is my second, like what I would say, an idea. And what is more important is we have to improve the enrollment ratio in core engineering. For this, my suggestion would be like what every industry should predict the skilled manpower requirements, whatever be in all or at all levels, and that should be passed to a centralized agency. It could be a government or any professional bodies like International Society of Automation, where what they do is sector by sector, stream by stream, they will, what I would say is predict what will be the manpower requirement, and that should be projected to the public domain. And in turn, it will help school students to select groups. After 10th, they'll be able to select the right group, be it computer science, or it could be engineering, or arts, or it could be commerce. So it will help the students to select the right group after 10th, and after 12th, they'll be able to select the right choice of engineering, be it electronics and instrumentation, or ECE, or computer science. So every industry should come forward and foresee the manpower requirement, project the requirement to a centralized agency. As a result, now we'll be able to improve the enrollment student ratio in core engineering, because now school students are clueless. They don't know about the opportunities that are available in the core engineering, and most of their choices IT. But there are a plethora of opportunities in the field of instrumentation, I would say, in core engineering. And if they know much more about the field of automation, then every engineering institution will be able to nurture their skills, and we can help in enhancing their skills in their core domain. And as a result, we'll be able to maximize the talent pool in all the sectors. And there is a paradigm shift in the teaching learning process. Earlier, if you see, it was teacher-centric. Now we have moved from teacher-centric to student-centric, and there are several teaching learning methodologies available: blended learning, digital learning. And my suggestion would be, and we promote in our campus, we promote in a big way experiential learning, that is learn by doing, for which what is required is industry and academicians, they should come forward, and in each and every class, a faculty member and an industry expert should handle a specific topic, and thereby we'll be able to enhance their learning. So that is my suggestion. So here, in each and every session, industry experts as well as faculty members should come forward and handle a specific topic. Whatever be the subject, it could be process control, or it could be communication, whatever be the field. So teacher and the industry expert should handle each and every topic. That is my suggestion. And now in a big way, we are promoting a skill development. So my next suggestion would be like, we have to create database of experts in all domains, so that engineering colleges, university will be able to make use of their expertise, and thereby we will be able to enhance the core competency skill of students. And also, in a big way, we have to promote what I would say academia-industry collaboration. Industry experts and faculty members should jointly author textbooks. We have to jointly prepare case studies, like what is happening in medical field. We have to share our success stories. For example, the commissioning of boilers, commissioning of turbines, all that success stories have to be jointly shared to the students. So we have to, it should be jointly prepared by faculty members and students, and it should be presented. And online lectures in emerging areas of instrumentation, like for example, safety instrumented systems, commissioning of automation plants, all that, it should be jointly prepared and delivered to students, and thereby we'll be able to enhance the core competency skills. jointly experts and faculty members should guide students, projects at UG level, PG level, at a research level, and faculty training, that is very, very important. Industry should come forward and train faculty members, and thereby they'll be confident, and they'll be able to enhance their skills, and then in turn impart high quality education to the students. And also joint supervision of projects. All that should happen. As a result, now we'll be able to enhance the core competency skill of students. This is my suggestion. And in a big way, what we have to do is that we have to promote experiential learning, that is learn by doing. So for that, what is required is the academicians will be able to impart only theoretical knowledge. We will not be able to impart practical knowledge to the students. So as a result, both industry experts and academicians should join together. And in a big way, we have to promote experiential learning, for which we have to establish virtual labs, specialized labs, and thereby we'll be able to enhance the skill development. And there are many schemes promoted by central government and state government. Our state government recently, they have promoted a scheme called Non-Mudalvan, where they offer like courses which are not offered by academicians. So that with the help of experts, courses are being developed and are being offered to the students. So my humble request is engineers, school students, and I would say engineering students should make use of this. The schemes are promoted by central government and state government, and industry should come forward and offer a lot of courses. As a result, we'll be able to enhance the core competency skill of students. So these are some of my suggestions. So in a nutshell, what I would say is we should, like the academicians and experts should come forward and offer courses. We should offer guide projects, and we should establish laboratories. We should not work in silo. As a result, we'll be able to enhance the core competency skill of students. We'll be able to maximize the talent pool in the field of, I would say, not only in automation domain, in all domains, be it civil engineering, mechanical engineering, or mechatronics. With this, I would like to thank the organizers for having given me this opportunity. Thank you.
Thank you so much, sir. Our next speaker, a strategist and implementer, the one ensuring high sustainable growth in top line and bottom line, achieving revenue, profit and business growth objectives within startups, corporate reconstruction, and rapid change environments, with an ability to think out of the box and contribute ideas towards achieving operational excellence. To speak on the topic of industrial automation, I'd like to welcome the Managing Director of Yokogawa India Limited, Mr. Sanjeev Nath.
So, good evening, dignitaries, and good evening, ladies and gentlemen. It's a pleasure to be out here. I brought such a large document, so be patient with me. But anyway, the topic is about sustainability, and sustainability is not easy, because I believe sustainability links society and societal values. And creating the values for sustainability begins from when we are a kid, right? I'll just give you an example. You go to Japan, since I work for a Japanese company, I quote a Japanese example. If you walk down the street, you will see a mother and a child walking together. If the child drops something on the road, the mother, without getting angry on the child, will patiently wait till the child, who is 2 or 3 years old, lifts that material and puts it into a bin. That for me is culture. That for me is learning. That for me is the basic ingredient of sustainability. Because everything that we try to preserve or recycle or change, that is what we call as the initiative as a kid to an adult to bring in sustainability into our lives, into our blood, into our basic genes, into our basic head. Today, as we talk, industrial automation from the era of pneumatics has undergone a lot of change. I think if you talk to Mr. Mehta during his younger days as the architects of automation, he would ask for a lot of data. Today, if you ask the modern engineers, they will say, how do I decipher data? The older generation had the skill set to decipher data. The new generation is dependent on computers, artificial intelligence, robotics, to interpret that data and give it in a form that can be used in a manufacturing plant. I think that's the difference the society is going through. I think these are aspects which govern the basic core of sustainability. And in fact, in the 70s and 80s, when I used to see the Walt Disney movies, or I used to see Star Trek or any of those sci-fi movies, I never thought that those equipments which were used at that period of time would become a reality in today's world. But that's how mankind has progressed. Narayana Murthy once said, in God we trust, but in data is what we believe in. I think today it goes a little bit more. To believe in that data and use that data becomes the critical aspect of how we innovate. I think that's the challenge of digitalization, and that's the way industrial autonomy starts progressing. So we heard a lot of experts talking about information technology and OT and the need for having OT experience. And I can tell you one thing, we will see sinusoidal waves as we go ahead, because today, information technology rules. Tomorrow, the scarcity of operational technology will ensure that operational technology people command a premium. We are already seeing that happen. IT, OT experience is not common. Today, if I have to deploy industrial automation or industrial autonomy, which I'll come back in a little bit later, IT and OT congruence or IT and OT knowledge becomes critical in actually shaping the future of manufacturing plants. And what is interesting is when I look at some of our youngsters, and they come from various streams, they come from electronics and telecommunication, mechatronics, whatever it is, or even from the IT field, if you ask them to interpret each other's disciplines, it's not so easy, because the skill set of the basics sometimes is lacking. Because we have got so used to cut and paste technologies which Microsoft offers, we have forgotten the basics of how equipments, machines, and technology works. A child might be very good at WhatsApp. A child might be, who's born is very good at Telegram and all those communications, but you ask him simple basic mathematics, it can become a challenge. That's where the challenges of future technology and future generations is going to happen. And that's where I bring in the concept of artificial intelligence and industrial autonomy. Because what the human mind lacks, the human mind wants the computers to do. They want that equipments learn the things by themselves, understand it, diagnose it, and actually do the operations for them. And this is interesting because this is the need of the hour in various parts of the globe. Somewhere the challenge is older populations, demographics. Somewhere you have young people, but with an attitude that when there are machines to do these things, why should we be doing it? So that's going to be an interesting, I will say, conflict, but at the same time marriage between autonomy and sustainability and people. In fact, we actually took an in-depth study in 2021 with about 534 respondents from 390 companies across 7 global markets and 7 industry sectors to understand the future of industrial autonomy. And 45% of the respondents from manufacturing companies say that industrial autonomy will have a significant impact on environmental sustainability in the areas of energy optimization, water management, and emission reduction. The implementation of these projects in the autonomy sector is with 51% of the manufacturers surveyed. They are looking at scaling deployment across multiple facilities and business functions, and another 19% reporting that they have full deployment in at least one facility or business functions. And what is the reason why they are going in for autonomy? About 31% of the respondents felt it's because of the return of investment, but the second critical aspect is 20% felt it's for health, safety, and environment. So I think these are two different aspects why autonomy goes into different aspects. And normally, what's also interesting is everyone wants to get into the digitalization journey. And today the budgets are with the CIO, which is the Chief Information Officer, and the CDO. It's no more with the plant manager or with the plant maintenance people or the project people, to be very frank. A CDO comes into the discussions of automation, and what is also interesting is in one discussion of a distributed control system, nothing regarding the control system was discussed. It was about what sort of server class machines are you serving, what sort of PC configurations are you giving, what sort of networks are you going to give. So it's interesting. So it's about who can answer the IT questions better gets the order. Huh? That's the part of the reality. But tomorrow, I believe, these same CIOs, when faced with business challenges when the OT platform does not work, will start creating experts who will start questioning this sort of things. And the congruence of OT and IT becomes critical for the success of the future plant. Now, industrial automation is required by most plants, but what levels of industrial autonomy can you go? You cannot make a plant autonomous across all suddenly. So you have to see for yourself what level of digitalization is critical or what level of digitalization is prevalent in your plant. The best of the consultants will give you Bibles. And I was talking to a customer, he said, I have a consultant who came and gave me about 12 book volumes, and I don't know where to begin with. That's because the Bibles has a lot of information, but sometimes it forgets the ground reality. And looking at the ground reality becomes critical for vendors and users to actually collaborate and partner to make the dream a reality. The second part of the autonomy plant is, just for example, today's artificial intelligence that we talk about. We actually did a plant in Japan which ran on artificial intelligence for 31 days without human intervention. And that, I believe, was a significant breakthrough or a first throughput, what we as a Japanese company did. And the reason for that was because the traditional control could not have been implemented in that application. It required different sort of skill sets. It had safety. It had environmental challenges, which required artificial intelligence to actually learn the business model and actually work across it horizontally and vertically. I think 31 days of autonomous operation is, as you would say, one small step for mankind. Because this is what we call as cutting edge innovation to actually change the way future plants will actually operate on. Last but not the least, I think sometimes I'm a little bit saddened when, I hear people talking technology and not giving the due credit to electronics or instrumentation people. And the reason why I say that is the best of plants will not remain stable, will not have the necessary throughput if you do not have the best of engineers in all fields. So I think it's for us to actually create a society where education is valued just not for information technology. My own daughter, she believes in information technology. I think that's a generation that goes. But in the future generation, I think we have to change this, because if we don't change this, we will have a shortage of good people who can run plants. That's the basics. The basic core of engineering cannot be ignored, because whatever aspect of digitalization happens, there will still be machines, there will still be people, and you still will need human intervention sometime or the other. You don't want Union Carbide to repeat, and that's why we need people, intelligence, and automation and autonomy. And as I conclude my speech, I think I want to quote Stephen Hawking, actually. And he said, for millions of years, mankind lived just like animals. Then something happened which unleashed the power of our imagination. We learned to talk, we learned to listen. Speech has allowed communication of ideas, enabling human beings to work together to make the impossible. Mankind's great achievements have come by talking and listening, and one of the greatest failures is when we do not listen or when we do not talk. It doesn't have to be like this. Our greatest hopes can become a reality in the future. With the technology at our disposal, the possibilities are unbound. All we need to do is make sure we actually listen and talk. So the whole point is, it's about education. And I want to link it to MIT's professor who said, you know, we have to make the people more educated. I think it's a corporate initiative also. It begins with people like us. So let's join forces to make at least India sustainable, and then the globe sustainable. Thank you very much.
Thank you, sir. We see thoughts meeting there. Our next speaker comes with 32 years of extensive experience in the energy industry with diverse expertise in project management, business development, procurement, project services, and general management. Right from his first day with Larsen & Toubro to his present day in Technip India, there's a solid background in projects and operations. He aims to further strengthen Indian operations with a focus on enhancing the energy transition portfolio while retaining the company's leadership in high-value EPC, PMC, and EPCM services. Hence, to talk about and share his views on green energy and hydrocarbon, let's welcome the Managing Director, Technip Energies India Limited, Mr. Devendra Kumar.
Good evening to all of you, and thank you very much, IED, for giving me this opportunity to be face-to-face talking on certain aspects related to the energy transition. First of all, I don't belong to instrumentation and controls. I'm a mechanical engineer by background, and the industry in which I work is more about process and chemical, but of course, every discipline is playing an important role there. So maybe just to give you a brief background about Technip Energies as a group and in India before I move to the topic of energy transition and sustainability. Technip Energies has got 60 years of experience, but it's 2 years old company, a startup you can say. We are listed in Paris Stock Exchange. Our last year 2022 revenue was 6.4 billion euros. As of March 31st this year, we have a backlog of 12.8 billion euro. We have 15,000 plus people all over the world in almost 35 countries. We are present there. And we are basically a technology and engineering companies who does project delivery and the services. We have delivered some of the largest projects in the world. The largest floating object on the earth is Prelude FLNG, floating LNG, which was done by Technip Energies. The largest project executed LNG in Russia was by us, Yamal. So that's the background of Technip Energies as a group. And if we talk about Technip Energies in India, we are close to 4,000 people here. We do all kind of projects, EPC, PMC, EPCM, EP, feasibility studies. The largest project, EPC, which we are executing is close to 3,700 crores for IOCL. The largest PMC project, which we are doing is close to 2 million hours, where we are handling close to $3 billion USD investment on behalf of IOCL again. We also have Bogota Center in Colombia and Bangkok in Thailand as part of our India operating center, which brings us to our overall strength of close to 5,000 people. So that's the background about the organization. And as we move towards energy transition, last year we reorganized ourselves, the organization at the corporate level. We put our organization into 4 business lines. One is gas and low carbon. Second is SFCC, which is sustainable fuel, chemicals and circularity. Third is the carbon-free solutions, which talks about green hydrogen, nuclear, wind. And fourth one is about 10X, which belongs to assets lifecycle, PMC services. So this is how we organize ourselves, and the basic purpose was to be close to our customers, to make sure that we create, innovate ourselves in line with the energy transition demand. And we also created a 110 delivery, which is the execution arm all over the group. And if we talk about our backlog from the conventional business, which is mainly into LNG and SFCC, and what we see a growing need of decarbonization in LNG. The largest, one of the largest projects right now, what we are doing in Qatar, which is NFE. There, along with the LNG train, we are doing carbon capture, and we are able to reduce the CO2 emissions in that particular train by 25%. We are also on the SFC side, when we talk about traditional business in refining and hydrocarbon sector, again, there is a growing need to reduce the carbon emissions. We are working with our customers, with our partners to do the carbon capture, do the electrification, use renewable sources, have more efficient furnaces. Some of the customers we are discussing where we are going to use hydrogen in the furnaces. So in all these gambit, we are trying to decarbonize and make the world more sustainable. And when it comes to today's topic, which is about sustainability, the overall purpose, the mission statement for Technip Energies is about breaking boundaries to engineer sustainable future. So it exactly matches what we are talking about the things today. And just to let you know, in 2021, out of our portfolio of 6+ billion euro, on the energy transition side, we were only 200 million euros. And last year, that portfolio increased to 1 billion euro. So we are executing 1 billion euros of energy transition projects, which excludes the LNG. It's a significant market share in terms of energy transition projects, and it shows our commitment towards the world, towards the industry, that we are acting as a bridge when we are making the transition from the conventional energy to the future energy. So there are 3 aspects on which we are working. It's about carbon capture, the circularity, and the green hydrogen. On the carbon capture side, we have a tie-up relationship with the Shell Catalyst, where they have developed a technology which is called as CANSOL. So today, if we want to meet the 2050 target of net zero, some of the countries have already committed. It will not be possible without capturing the carbon emissions from the existing units or the plants which are coming up in the conventional way. The estimate says that by 2030, it will be 1.2 gigatons of carbon emission which needs to be captured, and by 2050, it will be close to 6.4. And today, as we speak, it's only 40 million ton we are able to capture. So there is a huge gap in terms of development of technology, in terms of putting up these carbon capture units, if you want to achieve the net zero target. And we are working on it. The world's largest carbon capture plant in Norway, Oslo Celsio project, is being executed by us. And once executed, this is going to reduce the greenhouse gas emission up to 17% of Oslo in Norway. We are also working with Svante, that's another technology. The other one, Cansol, which I talked about, is on liquid absorbent solvent basis. And with Svante, which is a startup which are developing a technology which is dry based, where we use the circular filters with nano filters and sieves to capture CO2 emissions from the flue gases. That is being again promoted by us along with Svante to make sure that we are able to meet the future needs of the industry to capture carbon. On circularity, we have a number of technologies where we recycle the plastics. We are working on recycling even the polyesters and make sure, because more and more demand is created, and one of the best ways to control the environment, manage the environment, is to reduce consumption, which is not going to happen so easily. So another way is we create a product which is reusable, recyclable, and this is where some of our technologies help us to recycle the products right from the design stage. We work on these things. The 21st century, if we talk about, the initial part was about the renewable sources, solar, wind, and the second half of this century is going to be green hydrogen, because this is where we feel the analysis says that we will not be able to achieve the net zero target if we don't have green hydrogen. And there are various challenges in front of us when it comes to green hydrogen. I'll talk about few challenges and how we are going to tackle that. So there are, this 4E challenge when it comes to green hydrogen. First is about the electrolyzer. This is the heart of this green hydrogen, and it involves very difficult technology still to mature. There are various technologies available: alkaline, AEM, PEM, and SOEC. Right now, what is matured is alkaline technology. The government has put up a target of 5 million tons of green hydrogen by 2030. And this is the vision of the government, to make India as the hub of green hydrogen for the world. But it's not an easy target. To meet this target, what we need is close to 35 gigawatt of electrolyzer capacity, and today there is hardly any capacity available in India. And worldwide also there is hardly any capacity available. Even if it is there, that's not available because those vendors are fully booked and we are not able to get the supplies. Recently, you might have seen in the newspapers, few organizations have come forward to put up these units of electrolyzers, but that's a journey. And on top of it, it needs some metals like nickel, platinum group, and some rare earth, which are not available in India, which are controlled by countries like China, Australia, Chile, and Peru. So what we need to do as an industry is to scale up the electrolyzer manufacturing, build that expertise, and tie up with some of these countries who have got these natural resources which are required to make sure we have this electrolyzer manufacturing capability in India. The second part is about the energy source. When we talk about green hydrogen, we need to have the green electricity. And for meeting this 2030 requirement of 5 MMTPA, we need close to 125 gigawatt of green energy, which is going to come from wind, solar, hydro. And the most critical part here is how to synchronize these renewable energy sources, because solar is available only during the daytime in some part of the world. So it also creates another issue in front of us, how to manage the intermittency, how to manage the renewable energy source to make sure we have continuous production of hydrogen. The battery part is still being developed, it's still not there. People are talking about compressed air to store this energy so that we have continuity to produce green hydrogen. The third part is on the end user. Hydrogen being a volatile and combustible component is not easy to transport. Then you have to convert into ammonia, bring it to the place where it is to be used, and then again crack it. It involves additional energy, additional cost. And then the last part is we need water. For each kg of hydrogen, you need close to 9 liters of water. And to meet this 2030 target, what the Indian government has set, we need billions of demineralized water. And water being a scarce resource, especially in India, is going to be another big challenge. We are talking about desalination, but it involves other challenges in terms of creating infrastructure, diversity. But these are the challenges in front of us. To summarize, there is no easy way. We need to have green hydrogen if we want to achieve this net zero objective. We need to overcome the cost barrier. Today, green hydrogen cost is 4 times the conventional gray hydrogen. So it involves, I know the 75% of the cost to produce green hydrogen is electricity. So it involves work on bringing the cheaper technology development on the electrolyzer side, which is again a big component in CapEx, to get the energy renewable sources, to optimize the cost, to make sure we come, the target by 2030 is to have Euro 1, 1.5 or 2 per kg of hydrogen, and today we are sitting at 7 and 8 euro per kg. A big task ahead, and the biggest challenge is everybody is talking about green hydrogen. There are a lot of feasibility studies going on. We have a lot of projects where we are making studies on this, but then the real investment is not coming on the ground, and the biggest barrier is the cost. So this involves a lot of technological advancement, and then coming back to what Dr. Prakash says, we need engineers, we need skilled engineers in the core sector, core discipline, to make sure we develop these technologies, we bring down the cost and make it happen. So this is another motivation in front of the engineers, and probably we all need to percolate it down and talk to our students that IT is important, but at the same time core business, core discipline is also important to take on this challenge. Also, this brings us to a challenge of sustainability in terms of our ESG. All these aspects are technical aspects, but we are also working to make sure that we achieve in a sustainable manner. So Together by 10 is our ESG roadmap, where we talk about it based on 3 pillars, where we talk about our climate environment, we talk about our people and the trust. When it comes to the environment, we have already defined our scope 1 and 2 emissions. From 2019 level, we have reduced it by 11%, and the target is by 2030, we will be net zero as an organization on scope 1 and 2 emission. We have already defined our scope 3 emission on upstream side, and the target is by 2023, we will define scope 3 upstream and downstream emission, and by 2050, we will be net zero on our scope 3 emissions. On people side, gender equality, today we are 29.7% of women in our organization, and target is to have 35% women by 2030 and 50-50 by 2050. And for that, we have ensured that whenever we go to the universities, we make sure 50% of our intake is coming from the women's side. And for last 3 years, we have been able to meet this target at the group level as well as at India level. This year, we had close to 215 graduate, and out of that, 50% is coming from the women. We have already set up a target of, on the training side, where we are going to spend close to 40 hours per person per year, mandatory on the training, to make sure the skills which are required on the energy transition side, we are able to impart those skills, we are able to upgrade the skills of our people. And in the leadership position, we are going to have 25% women by 2025. So that's the target on the people side. On the trust side, today we have 30% women in our board at the corporate, and by 2025, we are going to have 40% women in the board positions. We are going to ensure that our suppliers and contractors, they follow exactly the same ESG requirements, they follow the sustainability requirements, and we are going to make sure 100% of our suppliers and subcontractors will be compliant to ESG requirement by 2025. And also on the human rights side, all our projects will have the audit to make sure that we are complying with the human rights by 2025. So this is, in nutshell, about the Technip Energies and how we are going to take on this challenge of sustainability, net zero. And we sincerely believe that it's not possible on our own. We are investing a lot. As of today, 83% of our R&D investment is only on the energy transition technology side, and by 2025, it will be 100%. But still, it will not be sufficient. There are so many things required to be done. So there we are partnering with various other organizations who have the same objective of energy transition, sustainability, net zero ambition, and we are working along with them to develop various technologies. Some of the organizations where we are working for wind farms is with Equinor, on the plastic circularity with Epichem and Agilex, with Baker Hughes for the LNG modularization. So these are some of the organizations where we are partnering with them, working with them. And just coming back to what Dr. Mehta said, going back to zero, reinventing zero. It's coincidence, or maybe more than that, that the India gave centuries back zero to the world. And it's time again to give net zero to the world. And it's our time, India's time, a lot of opportunities, but I think we all need to come together to take on this challenge. Government has set an ambitious target of being the world leader in green hydrogen. We all need to work together, whether it's digitalization, the core business, everybody has to come together to meet this target. From our side, from the organization side, we are fully committed to meet this target, to have sustainable future, to develop sustainable technologies and work towards the ET side. So thank you very much for the patience hearing. Looking forward to interact with you and collaborate with you wherever possible to make it happen. Thank you very much.
Thank you, sir, for not just sharing those facts, but also for kind of pushing everyone towards the target. We have another speaker, and this time we are talking about a very crucial topic. With 25 years of experience in the industrial automation and product development, he joined ABB in 2003 and has held various positions spanning engineering, software, and product development, product managing, and sales. He brings in-depth knowledge of the advancements leading to a new industrial revolution by making manufacturing smarter and solving complex problems across the entire energy value chain. He's here today to share his knowledge on cyber security. Ladies and gentlemen, let's put a round of applause for Mr. Mangesh Navarange, the Sales Director, Digital Energy Industries Process Automation, ABB India Limited.
ABB, probably most of you know, but a brief introduction. We are a listed company in India. We are a listed company elsewhere as well. We are there for more than 100 years, present in 100 plus countries and 100,000 plus people. So that's a very short and a simple introduction. Today, the way ABB operates, we operate as close to 20 businesses headed globally with a single profit center allocation. Today when I was invited here, IED, thanks for that first. I was kind of happy. There is a lot to talk about, sustainability. And then they said, within that it's cyber security. The problem is sustainability and cyber security, they are rarely mentioned in single sentence. I have never seen both these subjects discussed in a single sentence. But having said that, why it happens? Because when we talk sustainability, in a way it's tangible. We see the electric cars, maybe when we are, traveling countryside, we see the wind turbines, we see rainwater harvesting. So we see a lot of things which are tangible and we say, yeah, that's sustainability. And what about cyber security? It's all hidden, right? The very world that we live and, the ecosystem we live in, it's, everything is based on technology. And the moment we talk technology and the massive infrastructure, right, the day-to-day activities that we do using a mobile phone or computers, there is a massive infrastructure that goes behind it. And all of that needs cyber security. So it's all hidden. And it's always difficult to explain cyber security as a subject vis-a-vis sustainability. Really what happens is sustainability, when everyone talks about, the focus is about climate, the focus is about recycling, and Dr. Mehta explained it really well in his keynote address. So we call something called as a climate resilience, right? The sustainability part. What is important is, I believe that everyone should also talk about cyber resilience. These two should go together because to create a sustainable world, and the other speakers spoke various things in different areas, but one thing they all mentioned in common is the use of technology. When we talk about all industrial revolutions, it always the advent of technology. Industrial Revolution 1 to what we all are living through is Revolution 4. Some people are already talking about 5, 5G coming in, artificial intelligence, we heard from, Mr. Sajid. So what is happening is the revolutions are happening faster. So between first revolution to second, second to third, now we see, the number of years between two revolutions are reduced. I go back to 1970s, 1980s, probably, closer to the time when I was born. That's what Industrial Revolution, third wave happened. A lot of things converted from pneumatic to electronic. But still, a siloed automation world was created with Revolution 3. And then we know this computers came in 90s, and then, things happened in 2000. So what was happening is, most of the research, most of the inventions were coming from the government or the research institutions. In India, we can talk about ISROs, the DRDOs, or globally we can talk about NASA's and equivalents. But then when the internet came, inside our home, that's where the democratization started of technology. And then we know the pace, the rapid pace at which the technology advancement has happened. It is there for everyone to see. Now, with all this happening around, if we don't focus on cyber security, just to give few examples, in the automation world, when we talk about automation or the manufacturing industry or utilities or energy industry, whatever kind of industry, the first known global virus, as people talk about, affecting the automation system was back in 2011, Stuxnet. Some of you may remember this name, right? It happened in Iranian nuclear plant. The later investigation revealed that it was a state-sponsored. There are different political reasons for it, but leave it at that. And from there on till today, there are very many examples of cyber attacks on the manufacturing facilities, which was always considered siloed. We are not connected. We don't need cyber security. It was as simple as that. But when we Google, Google throws a lot of data, a lot of statistics. So Google says, one interesting statistics for this conference I was preparing. So one such statistic says the percentage, has gone up by 4,000% in last 10 years of cyber attacks. So that's huge. So what does it mean? That the kind of things that industry is trying to achieve together with the society and government, basically we are implementing a lot more of technology. Yeah? And no business today is running without connected assets, connected plants. So what is happening on the shop floor in a simple terms, the CXO level really wants to know, what's going on, and some of the decision making happens at that level. And when you create this IT-OT convergence, which we also heard in one of the speeches before, you're basically flattening the IT-OT hierarchy. So what happened is you have the IT force who is taking care of your IT cyber security, but now suddenly they have this new animal called operation technology, OT. And what happens is in OT, the kind of devices, equipment, technology that we are using, in first place, they were never designed with cyber security in mind. Any kind of devices we talk about, they were never designed with cyber security in mind. But now they are getting connected, so which is violation of first principle that, we are not connected, we don't need cyber security. So when that has happened, it has thrown new challenges to the IT team. And so cyber security problem does not become only IT related problem. And what it really needs is the IT and OT teams coming together to solve this problem. And why it is more complex? Because IT people say, data is very important, confidentiality of data is very important. And the OT person says, confidentiality of data is not important. I want to make sure my plant is running, there is no downtime, right? Availability. So conflict of priorities. And that is where, both these entities have to come together to really solve the cybersecurity problem for their business in a meaningful way. Now, next problem, when you go out in the market, look out for solution, again the same problem, problem of plenty. So many solutions available, it's very difficult to decide where to start. So that's another area. And where to start, there is always easy way or an easy starting point. Start with an assessment. First understand who you are, what you are, where you are. Once you know that, you can easily define your strategy, how to go about it. And plenty of material is available freely on internet. But just to give a context, ISA we all know, IEC we all know, these are global bodies, and there is a standard called as 62443. Okay. Now, this is recognized by United Nations and the only consensus-based industrial cybersecurity standard today available. Not to say other standards are any lesser or less important, but that's a good standard to refer and to begin any activity which is related to cybersecurity. So that's very important. Now coming to the energy, I work closely with energy because I spend a lot of time working in power plants, now spend a lot of time working with oil and gas industry, and both are very important when it comes to the sustainable way of doing businesses. The energy transition part. We all know what is happening with the electricity revolution. We don't generate energy with thermal anymore, and when I say that, we don't generate new energy with thermal anymore. So addition of energy capacity is more and more from the renewable sources. We all know that. Now, the landscape is changing. Renewable is volatile, unlike the conventional sources. It is decentralized. We are not generating energy only in one place. It is decentralized, distributed. The grid is interconnected, grid is becoming bidirectional, grid is becoming smarter, and all of this needs technology to solve the problems. Yeah? And the moment you need technology to solve the problem, we talk about cybersecurity. Yeah? So it goes hand in hand. So what is important is, especially I know few managing directors are also there in today's forum. So cybersecurity is also discussed in boardrooms, okay, because there are repercussions to it. A recent cyber attack, just to quote it, Colonial Pipeline in US, many of us might have heard about it, where they had to shut down their operation and the facilities were out of gasoline, etc., etc. They had to pay millions of dollars, numbers I don't know, some of us may know it, millions of dollars to this hackers just to release access to their system, right? And the CXOs know what it means to pay that amount of money when they talk about the top line, bottom line, all kind of parameters. So that way it is damaging to the reputation, to the brand as well. But at the same time, there are other instances, for example, petrochemical plants, where the hackers actually weaponize it. So if you don't pay the ransom, you know what a chemical released in the climate, what kind of damage it can cause. So what's happening is going out for a war with a nation, it's a very costly or expensive thing. But cyber is a very easy tool, less expensive tool, and we are already seeing that. Some of us also remember this Ukrainian grid, which went down in 2015, 2016, which was investigated as a cyber attack. Yeah. So in future, cyber also will be used to weaponize these strategies, between the hostile nations. So those are the important factors why cyber security is needed for sustainable businesses. Yeah. We don't want to pay ransom. We don't want to see damages to climate, people, society, all kind of stuff. So that's why the focus is important. And maybe one of the simple suggestion is include cyber security as a part of operation risk assessment. Okay, we don't see that happening very often, but that is one easy and simple way to get started. Um, there are other suggestions which I have read when I was reading some material where it says at a corporate level define what is an acceptable downtime in the event of cyber attack. Okay, and then you know your preparedness. So these are the areas that probably the industry needs to look at, and it should not be like sustainability is something like a corporate social responsibility or the corporate vision, and cybersecurity is something of a governance and regulation. You know, that's a wrong way of looking at it. So both the link between sustainability and cyber goes much deeper than probably what it appears to be. So before I conclude, please remember sustainability is tangible, cybersecurity is hidden, but both go hand in hand together. So with that, thank you very much for the patient listening.
Thank you, sir. With that, we come to our next speaker. His strengths being direct P&L management for APAC and the Middle East, strategic and profitable growth mindset, execution capabilities, leadership engagement, building, developing, and leading multicultural teams across regions, and moreover, he being an expert on digital transformation. For the past 30 years, now he spearheads the Green Yodha. Well, if you have doubts about what that is, I think let's listen to our next speaker while he speaks on digital transformation for sustainability and resilience through next-gen automation. Let's welcome the head industrial automation, Schneider Electric India, Mr. V. Senthil Kumar.
Good evening, everybody. It's a great pleasure to be with you all. And now I stand between you and bit of an entertainment. I'll do my best to be short and engaging as much as possible. Sustainability and digital transformation. Unlike Mangesh, I don't find it difficult to relate. Thanks for that topic. Let's say that there are multiple ways by which everybody can contribute with every technology can contribute with sustainability, and green hydrogen is the best example. It's a real game changer. But one thing common everywhere is electricity. Okay, at Schneider Electric we say that two weapons, two ammunitions for us: more electric, more digital. More electric is easily understandable. More efficient form of electricity, and as we more electrify the world, we get to a sustainable future. And then as more and more green technologies power this electricity, this compounds further our march towards sustainability. The other pillar is on digital, more digital for Schneider. So today I'm going to restrict myself on that. Digital, what all digital or digital transformation can do in terms of sustainability. Let me start with the challenges, if I may summarize, and particularly in the last 2-3 years, COVID, and maybe a couple of years before COVID. Multiple challenges what in the market environment customer faces. Supply chain disruption from COVID time, heavy inflationary situation, unpredictable geopolitical situation, name not. So the market environment is significantly volatile. But the customer imperatives are increasing. We want more with less. We want more output with less of resources. Want to be more efficient, optimized assets, optimized plant. And that is significant. So on one hand, the uncertainties and the volatilities are increasing, and the demands from customer, rightly so, are getting sharper. And this is where I see technology. And the third challenge is that ever-changing technology. It used to be in the IT world. We spoke much on the IT, but even technologies with industrial automation and the digital technologies and the software we use is seeing significant evolution, right? So there are a couple of challenges, and third one is also a challenge, but if we adapt to the change, the rapid change in digital technology, we would be in a position to overcome the volatility of market environment and as well and meet the customer imperatives. All of us have customers. What we are trying to do is that meet their requirements. And I see this as greater opportunity. On a lighter note, not just that, Prakash has brought in, and even Sajeev mentioned on ability to attract talent. More and more digitization is going to attract talent which wants to get to the industry. Right? The people who want to be in IT, people want to get to that. If I may put a parallel, the BFSI industry, the banking, finance, insurance, was getting automated. That's where IT really was very attractive. And all of us read a lot, and it's very clear it's age for industrial, the manufacturing environment, to embrace this digital transformation or the information technology. More and more, we are getting there. Agnostic software, agnostic hardware, I may touch upon that specifically. So by leveraging these technologies, what we see, we would be in a position to really support the sustainability march for everybody, most of the customers, and the technologies are really awesome. Let's say that, what are the benefits? How does this digital transformation help it? To keep it simple, not getting into the technicalities, smarter control, and smarter and empowered workforce, and more optimized, efficient assets. This would summarize how these technologies can help everybody, any industry, you take it, any industry. And whatever he mentioned with respect to electrolyzer and the requirement, and we are engaged in some of those projects. And then more efficient we become, more optimized in that, some of the problems what you see in terms of electrolyzer would get better. So everywhere these technologies can get it. So what is a smarter control? All of us know that multiple layers of automation, and each organization would have its own nomenclature. At Schneider Electric, we call it EcoStructure. 3 layers, L1, which is the connected layer, and then L2, which is a layer of collect. We collect the data where edge control, all the PLC, DCS comes. And the third layer is about analytics, right? So in couple of decades back in L3 would be just a DCS software or a SCADA which controls PLC. Now L3 is much more than that. That's a real convergence of IT, OT we spoke about. In all these three layers, the connected layer or the edge control collect layer or the analytics layer, significant amount of technology development happens. And if we leverage a real digital transformation, driving optimization, efficiency on every process, leading to significant reduction of inputs, raw materials. It could be power, it could be any raw material, and aid in better decision making, and that's where digital transformation significantly contributes to sustainability. Starting at the L1, currently, in maybe a couple of decades back, communication, the protocols, most of the engineers here would recognize protocols were most important. But now the revolution in that connected layer, the early device has gone significantly higher. They are much more intelligent, much more independent. Most of the control happens in there. You take a drive, now we are pushing down the controller. As it gets much more intelligent, the ability to collect more data, and Sajeev already mentioned on data being the key, and how do we take it. So we are getting to a stage that the data integrity and the data quality at the connected layer is significantly up. And everybody is investing, and also cybersecurity. Mangesh has mentioned a right point in terms of earlier days, we never had the hardware, the connected layer, your drives or PLCs or any controller were not connected, but these days that's being taken care. We also have that's a more intelligent, more safer, connected layer is going to ensure a kind of data quality and data integrity which would support better decision making and which would support the next level where we get into L2 edge control of the collect layer. In this collect layer, again, technology is helping, as I mentioned, regarding agnostic hardware. What do we mean by agnostic hardware? We know that edge controllers for PLC DCS were kind of proprietary of various organizations. Most of them we are available here. But we are getting to a stage of much more independent PC control, IPC-based control, where the underlying hardware is becoming agnostic. Still, there would be hardware available, but it doesn't matter. That's IEC 61499 for whoever is following. That's a revolution happening in the edge control, the collect layer, second layer. And that's where, and Schneider, we call it Echo Structure Automation Expert. So that's one of the technology most of the organizations are bringing it. And that is much more powerful in terms of its ability to optimize the process to a level we have not seen. And that's going to provide a better process control, much more efficient for process control, and better optimization. So that's a contribution. The developments of the edge control L2 layer is leading significantly to the sustainability goal. But the most interesting is in the L3 layer, where a couple of decades back, as I mentioned, would be SCADA by and large. Over the SCADAs and above, a significant amount of analytics. Agnostic software, again, plenty. Everybody has it. Most of the organizations has it. And these agnostic hardware, if I may split into four, starts at the design stage, and then as well as an engineering tools for engineering, and then process optimization or process control, host of tools, and as well as for maintenance. A complete spectrum of design, engineering, optimize, and maintain. Significant level of agnostic software. When I mean agnostic, it doesn't matter whether we have an ABB, Yokogawa, or Schneider, or Siemens, doesn't matter. And these tools leverage all the data and bring in analytics and dashboards and support significant level of decision making. And this is what we call it, the shop floor to top floor. So it's a revolution. Digital transformation, what it's happening is starting at the shop floor and connecting to the top floor. The other way of calling your OT, IT integration. And that's where a significant development in all layers are happening. While technologies like green hydrogen and unconventional energy or renewable energy are significantly supporting, digitalization is a common phenomena across all industries, driving us to a better efficient operations, better efficient process, and optimized asset, and a set of tools by which our decision making is going to be much more sharper, much more informed. All of this, it helps connects at the 3 R's of sustainability: reduce, reuse, and recycle, much more on the reduce portion. Whatever we mention, these technologies supports much more on the reduce portion, reduction of your raw materials, reduction of your power, reduction of your water, and that's where digital transformation is a biggest body of our sustainability. If I may quote an example to end, we are not allowed to quote on the customers. We work on food and beverage or CPG plants, and the amount of wastage, the amount of data integrity required in a pharmaceutical industry, we are aware of. Lack of it leads to significant amount of wastage. The level of data integrity being brought by this digital transformation is supporting pharmaceutical industry to a level where they would drive significant amount of savings. Another example is we connected unified operation control for a smart city, for one of the smart city project, smart water project. I don't want to name customers, so I don't take it in a western part of the India. And n number of remarkable amount of benefits we have got, but I wanted to bring is about, we all know how water gets losses in water, right? Significant amount of losses. was primarily due to lack of ability to predict. Lack of ability to predict across. Let's say a complete city. We all connected it, all the layers, the connect layer and the edge control collect layer and the analytics brought into an unified operation command center. We call it UOC. And the result is 10 to 15% reduction in losses. That's sustainability. Reduction in water, which is most crucial. Another example is on the power generation and the automation of complete energy industry. The loss, what we see, smart metering, what you're seeing it, and the ability for us to leverage on the smart metering in the substation automation or complete energy life cycle automation. Significant amount of power saved. We all know that saving power and saving loss of water or any form of resources significantly contributes. So that's a significant contribution. So how do we do it? We need to have partners who are also, like what you mentioned, making the entire ecosystem of your partners also imbibe the culture of sustainability, and then arrive in systems and process by which we support our customers. So concluding, ladies and gentlemen, as I mentioned, I kept it short and engaging, hopefully. So digital transformation touches all aspects of industrial or large networks, across all public networks. And the scope for us to optimize and drive efficiency and drive data integrity to decision making, which also supports sustainability, is immense. With that, I thank for the opportunity and your attention. Thank you.
Has a wide exposure in basic and detailed engineering, procurement, project management, construction and commissioning. He has the expertise in managing the total engineering and project cycle, covering all engineering disciplines, and has traveled worldwide on various projects and assignments. That is exactly what makes him the right person to share his point of view on the important topics being discussed this evening. Ladies and gentlemen, please put your hands together for the consultant in Technon Engineering currently, Dr. V.P. Raman.
Good evening, ladies and gentlemen. It was a grand introduction and hope I am able to sustain that. That will be my first step. Now, we have heard speakers talking on the various subjects. Excellent topics. First, I would like to ask whether there are any queries from any of the people, any audience, any queries? Because we are ready to take up one or two questions. You may ask the question so that we can address it to the concerned people, so that they can express their views on that. So everybody understood everything. No questions asked. Very good. Excellent. Very nice. Well, so now I think it is time for me to ask a question. Well, first of all, I would like to thank Dr. Prakash for giving an excellent perspective regarding the industry and institute coming together. It's very nice. Excellent. But see, we need to have one step beyond this as a motivational force for the students to join. So we cannot have everything at our will, because see, today's world is a materialistic world. Ultimately, an IT professional drawing more salary, he may be a backbencher, but he draws better salary. So when we talk about the core engineering, we need to give them slightly little bit more advantage. So what does MIT think or have plans regarding retaining, first of all, upgrading the skills, retaining the skills, and going into core competency? So if you have got any views on that, I will be more than happy to listen to it.
is we promote research at UG level. But mostly what happens is students, they will pursue their undergraduate program and then they'll pursue PG and then followed by PhD. But what we do at MIT is each and every student, UG students, we assign research projects, and as a result, they work on research projects, so they'll be able to foresee what is happening, and they'll be able to contribute in terms of product development, in terms of an algorithm, and thereby it helps in their career. In fact, I would say in the placement, so that they won't work on a regular kind of a project. So they work on a research problem, and as a result, they'll be able to contribute a lot once they join an industry. That's the kind of an edge every student gets at MIT campus.
Thank you very much, sir. Now to all the leaders, whoever gave the beautiful lectures on sustainability, how do you prevent the brain drain from India? I mean, you should have some sort of a roadmap to prevent the brain drain. We have got a lot of intelligent students who decide that, well, sorry, this is not the right place for me, they go back. They go to US. I think it is time that all the leaders think in a very positive way to find out how to retain the talent and prevent, okay, you cannot totally remove, prevent the brain drain. Now, we had a beautiful session from Mr. Sajivnath, who happens to be a close friend of mine, and he talked about the usage of data, IT and OT congruence, etc. Well, Sajiv, I have got one small question on this artificial intelligence. You talked about the artificial intelligence, very nice. But do you really think that this artificial intelligence is going to overtake the human mind at any point of time?
Well, it's an interesting question. Will it overtake or not? The future will say, and I do not have a crystal ball as of now. But the fact is, I think it's not going to overtake, it's going to be in parallel for some period of time. But I think the dependency of the human brain, or the human tendency to depend more and more on AI, will be something like an addiction. The bar is open, okay? So it will be more like an addiction towards the artificial intelligence as such. And the reason for that is, I think we all want an easy way out.
Right.
And when we want an easy way out, the things that come easily, we become more dependent.
Right.
If you have seen the development of the human mind from the Stone Age to now, I think it has always been the desire to do something that activated the mind, right? What will be challenging with artificial intelligence is the mind ceases to think.
Right.
So there is a possibility and there is a danger that artificial intelligence becomes so good that we all become dependent on it.
But don't you think that even an unskilled person who do not have the core competency will enter this arena?
I think it's already started with ChatGPT.
Okay.
I think it's already started. If you just go and Google things, even an unskilled person starts making sense, right?
Yeah, I know that somebody has even given a pass or fail in the university based on the ChatGPT.
So the whole point is, I think technology is here to stay. I think what's going to be important for the human brain is, or for the human mankind is, use it in a constructive way, but at the same time exercise self-discipline.
Thank you. Thank you very much.
Thank you very much.
Thank you, Sajiv. Then we had Mr. Devendra Kumar, who talked about, from the Technip, who talked about various things on the technological front. Fortunately, or unfortunately, green hydrogen happens to be close to my heart. But there are a lot of challenges in this green hydrogen, especially first of all, the production challenges, storage challenges, transportation challenges. And considering the hazard, nature of the hazard which it carries forward, I mean, it has got a lot of limitations. That's why we try to convert it to green ammonia and then again green. Don't you think that this particular process of what we are talking about, it's not going to be cost beneficial? Here.
So you're right, Dr. Raman, that you know, a simple way, as a layman, if say somebody is that from electricity, you are doing the electrolysis, you are producing hydrogen, then converting into ammonia, taking it somewhere, then cracking it, again bringing it back, reverse electricity. So what you are doing, instead of electrify the things and use electricity, but there are certain areas, whether it's aviation sector, shipping sector, where, and the other places where you cannot electrify each and everything. So you need some alternate source of energy. And at this moment, hydrogen seems to be the best placed. Now, coming to the cost part, yes, that's a big challenge. That's the reason projects are not coming on the ground. But if you look back in last 8-9 years, you know, when we started with solar, today solar is, you know, we started at 8 rupees a unit, and today it's 2.5 rupees a unit. Big reduction. If you talk about wind, same thing happened. On onshore side, there is a reduction of close to 45% in the cost. On offshore side, 32%. On the battery side, there's again 83% reduction in the cost. So it's an initiative, and I think in each of these sectors, whether solar or other places, the government has put up some policies. We have made the other industries or the other sources much costlier which are polluting, so that this becomes viable. And this is again in hydrogen sector also, we are sure once we have certain projects coming on the ground with the support of the government, the policy, the volume, the scale, when we reach that scale, the target of achieving $1 to $2 a kg, which is less than today, the conventional is around $2 to $3 a kg, is achievable. And the whole net zero of 2050 target is dependent on this. So what we need is a support, the policy support, the support from all the like digitalization is going to play a big role in this, how we deliver our projects, how we operate our projects. And that's going to be the key in achieving this. So it's a reality, it's a possibility, and we need to make it happen if we want to achieve net zero.
Thank you. Thank you very much, Devendra Kumar. Then we had a very interesting session from Mr. Mangesh on cyber security. Now the question was, is cyber security part of the sustainability? Well, gentlemen, it is 100% yes. For the simple reason, we were earlier talking about the laptops, then we talked about the edge computing. Today we talked about the cloud computing, big data everywhere. Now, how do we ensure that what we get is the right data, uncompromised data, without being hacked? So he made a very good presentation on cyber security, and I fully support that there should be an operational risk assessment study when the project is being in the proposal stage itself and being implemented at that stage. Now you said that sustainability is tangible and cyber security is hidden. Now, why do you say that cyber security is hidden? According to me, that is also a tangible. Because unless and until you don't merge and marry the two together, we will not be able to really get the real support of the big data, what we are talking about today. Am I right, Mr. Mangesh, what is your opinion on that? Here.
So when I say tangible, usually things which are visible, we tend to call them tangible. Yeah.
Okay.
So in cyber security, probably investing in a firewall is a tangible investment.
Right.
Yeah. But I mean, as you said, cloud, the data integrity, IT/OT integration, things have gone much beyond just talking about firewall. There are a lot of other things, other techniques, procedures, policies which come into picture, a lot of investment goes into it, yeah, and which is not necessarily visible anywhere.
Correct.
So that's the only difference, I would say.
Thank you very much, Mr. Mangesh. Thank you. Then finally we had Mr. Senthil Kumar from Schneider, who talked about digital transformation. Well, he talked about layer 1, layer 2, layer 3, etc. But digital transformation itself, yes, it is definitely going to contribute positive towards the sustainability. But my question would be, we are talking about digital transformation. There are a lot of software packages available. Like say, for example, before I build a plant, we do the modeling of the plant. I know exactly what sort of minimal efforts I need to do before I go to the construction site. And I'm fully aware that there are companies like Technip, Ude, etc., who have also got RFID tagged items being shipped to site so that they can ship the material according to the requirement rather than dumping everything at the site. Now, from my side, what role do you think the digital twin will play in determining the design as well as the operation part of it?
Oh, this is excellent question. So this is, you already spoke on the modeling, the benefits of modeling, the limited benefits of modeling itself it's bringing in. Companies were not adapting in the earlier stage, but now they are investing, as I mentioned, the agnostic software in the design and engineering stage. That has started playing a significant role in terms of design. But on digital twin, where the technology is evolving very rapidly, we are going a step ahead. The adoption is much more faster and the acceptability is much better, primarily because the benefits are also significantly different. They're in a position to design completely. It's like a walkthrough, a virtual walkthrough, and understand various elements. So the significant difference is modeling was based on assumption. Now you are able to assume and complete, if I may talk in the PID language, complete the loop with understanding whether it gives you benefit. So it's going to be a very significant role.
Thank you very much, Senthil Kumar. Thank you very much. So with that, we have heard our speakers. I have also raised certain queries to our speakers, and we had an excellent presentation. But now we talked about sustainability, and as per our Prime Minister, he has given a target of 2070 to come down the net zero. I mean, it may not be net zero, but at least minimum 60 to 70% by 2070. I think it is time that all the senior leaders or the industry stalwarts should put efforts to ensure that we achieve or bring down the emission rate, the reduction in the waste, everything to come down so that we achieve or move towards net zero. See, zero is again a question of probability. So to reach zero, we have to reach at least 1 before we reach zero. We are already in something in the region of 70. So 70 to 1, it's going to take some time. Fine. So with that, I don't think I got anything else, but I would like to mention only one small thing. You all may be aware that we are presently living in Kali Yuga. I don't know how many of you are knowing. The duration of Kali Yuga is 4,32,000 years, of which approximately 5,800 years have already passed in 2023. So but if you notice in the last 10 years, lot of damage has been done in the last 10 years, last 10 to 12 years. So the mute question is, are we going to stay up to 4,32,000 years? Is it possible for us to sustain to 4,32,000 years? So we need to take steps to ensure that at least, if not 4,32,000 years, at least for the next 100,000 years, so that our children, grandchildren, they all enjoy the benefit of being born on this earth and take the benefit of the advantage of the technology. Thank you very much, gentlemen. I don't have anything to say. Thanks a lot.
Thank you so much, Dr. Raman. shall now like to call upon the various speakers in order so that we can felicitate you. You take home a little memento of our appreciation of your presence here today. Thank you for sharing all the knowledge that you could with us. So the last words come from none other than Jyoti.
Thank you, Lavina. As Lavina mentioned, she missed calling me on stage for welcoming and so I must say this is a welcome and a thank you all summed up in one. At the outset, first like to thank on behalf of my father, Managing Director, Dr. Arokya Swami of IED Communications and our Board of Governors for Automation Expo South. I would like to thank all our speakers, Dr. Mehta, Dr. Prakash, Mr. Sajeev Nath, Mr. Devendra Kumar, Mr. Mangesh Navrange, Mr. Senthil Kumar and Dr. VP Raman. You know, all of you are fantastic panelists. Initially, I thought of starting that, you know, today we have experts who's going to talk on sustainability with an impact. So I must say that was an impactful 1.5 hours that we had. But automation we've been trying to do, talking about sustainability, but we always give you guys just 1 hour or 60 minutes, which is not doing justice. Absolutely no justice. So it's like asking you to sum up the entire ocean in just one drop. So maybe we'll look at doing some more displays on sustainability in the next Automation Expo. Very good time that we've had, and I do not want to talk further. Every one of you have shared your views. We had 7 experts and all of you delegates who have been, you know, attentively listening to all of them. I'm sure you have a lot to take away from here. And Dr. Prakash, Dr. Mehta, Mr. Sajeev Nath, Mr. Devendra Kumar, and we talked about your vision, we talked about the schools, we talked about cyber security, we talked about digital transformation, net zero and everything. So fantastic, and I would like to thank all of you, and I'm sure tomorrow is day 2 at Automation Expo South. We've done 15 editions of the Automation Expo 2022 to 2022. I mean 2002 to 2022 in Mumbai. This is our first maiden event in Chennai and 153 stalls. We are very thankful to all of you who have made it happen, especially our Board of Governors for Automation Expo South, our steering committee who made it happen. And to say what Dr. Prakash mentioned, we are taking this, but we are a platform that makes you display technologies. So as one step forward, we are talking about the India Automation Challenge, wherein we are inviting students to present their projects, and best 5 projects will be asked to display with some awards and all of that. And next step would be going to the schools. So this is something that we need all of you. As Mr. Sajeev Nath mentioned, the automation and instrumentation industry, I mean, you don't create opportunities, you make it happen, and you are the guys who make it happen. So I must say a big round of applause to all of you who make it happen. Thank you once again, and we look forward to seeing you tomorrow morning. Thank you.